This is a quick, very informal lesson on fractions. We're going to start off with adding and subtracting. Remember that when you want to add or subtract fractions, and I'll just make up two right now, here's an addition problem. You need a common denominator when you add or subtract fractions. So the common denominator for 2 and 3 is going to be 6. So I'll multiply this fraction by a 3 over 3. So I get a 6 in the denominator. And over here I'll multiply by a 2 over 2. So I get a 6 in the denominator. Once you have that common denominator, you just keep the common denominator and worry about the numerators. So 3 times 1 is 3, plus 1 times 2 is 2. So 3 plus 2 is 5. So my final answer is 5/6 here. Now let's take a quick look at multiplying. So I'm just going to slide the paper up, and dividing will be next. When you multiply, remember that you do not need a common denominator. So if I have 1/2 times 1/3, I'm just going to multiply the numerators and the denominators separately. So in the numerator I have 1 times 1, which is 1, and in the denominator 2 times 3, which is 6. So my final answer is going to be 1/6. The other thing I'd like you to keep in mind is this, and it might simplify things at times. If you have something like 2 over 5 times 20 over 4, let's say, you can cancel anything in the numerators with anything in the denominator. So you might notice that 5 goes into 20 4 times. So you can say 5 goes into 5 once, and 5 goes into 20 4 times, and just cancel like that. And now you can cancel the two 4s. 4 goes into 4 once, and 4 goes into 4 once. So what you're left with now, after you've simplified, is 2 times 1, which is 2, and 1 times 1, which is 1. So the final answer here is going to be 2. All right. Now let's slide up a little bit more, and let's do a division problem, and then we'll cover simplifying. So divide. So the rule is this: if you have 1/2 divided by 1/3, the rule is you're never supposed to divide. You're supposed to multiply by the reciprocal. All right. So you're going to take 1/2. And instead of dividing it by 1/3, you're going to multiply it by the reciprocal of 1/3, which is 3 over 1. And now you're doing a multiplication problem. 1 times 3 is 3, and 2 times 1 is 2. The answer would be 3/2, okay? Which leads me into the next little lesson, which is simplifying. So if you're left with something like this, 3/2, you're not supposed to leave it as a 3/2. You're supposed to say 2 goes into 3 once. There's 1 left over, so it's really 1 and 1/2. Okay? Another situation where you might want to simplify is if you're left with something like 6 over 8. You would simplify that by saying 2 goes into 6 3 times, and 2 goes into 8 4 times. So I didn't try to teach you everything there is to know about fractions, but just enough to help you on the ACT. This is a short and informal lesson on exponents. The first aspect of exponents I want to cover is this, that if you have anything raised to the 0 power, it equals 1. So x to the 0 power equals 1. 10 to the 0 power equals 1. Now here's where you need to be careful. If you have something like this, negative 10 to the 0 power, that will equal 1. But if you have this, negative 10 to the 0 power, that equals negative 1. What you have to remember is this, that the exponent only affects mathematically the thing that it's touching. So here, this 0 exponent is affecting everything here, the whole negative 10. So anything raised to the 0 power equals 1. But here, the 0 exponent is only affecting this 10. So 10 to the 0 power is 1, but then this makes it negative, so it becomes a negative 1. So be careful. If you have something like this, 2x to the 0 power, that's going to equal 2. Why? Because the 0 power is only affecting the x. So x to the 0 power we saw up here was 1, and then 2 times 1 is going to equal 2. So keep that in mind. And then if you have anything to the 1 power, it's just going to stay itself. It's not going to change anything by raising something to the first power. Okay? So let's keep going, make some more room here. A lot of kids get confused in this situation when they see x squared times x cubed, that's one problem, versus x squared being cubed. Okay, they forget the rule. Am I supposed to add or am I supposed to multiply? I'm not sure, I forget. So here's the deal. I just try to remember these two. X squared means x times x, and x cubed means x times x times x. So if you actually expand it and take a look at it, you can see the 5 x's here. And that might remind you what the rule is, that you're going to add the exponents in this case, so it becomes x to the 5th. Okay? And if we expand this now, this 3 is telling us to cube or multiply the x squared by itself 3 times. So if we did that, it would be x squared times another x squared times another x squared, and if we expanded that, we'd get x squared is x times x, and this x squared is x times x, and this x squared is x times x, and you can see the 6 x's. So this is going to equal x to the 6th power. So in this situation, you're going to multiply 2 times 3 is 6. Okay? The last thing I want to cover, I'm certainly not covering everything there is to know about exponents, but I want to cover what to do when you have a negative exponent. So the rule is this: if you have something like x to the negative 7, it's kind of bad form to have a negative exponent. So what you want to do is flip it to the denominator. You want to make it 1 over x to the 7th. Alright? And if you had something like this, like 1 over z to the negative 2, you would flip that to the numerator, making it a z squared over 1, and you don't really need to write the 1. Okay? And let me just give you one more quick example. If you had something like this, x squared z to the negative 3 over y to the negative 4 w cubed. Okay? It's only the negative exponents that you have to deal with in a situation like this. So when you take a look at the x squared, you should say, well, it's fine. There's nothing wrong with the x squared. I'm just going to leave it where it is. So leave the x squared there. Now this z is raised to the negative 3 power. That's going to need to flip to the denominator. So it's going to become z to the 3rd in the denominator. Then you go down here and you see that this y is being raised to a negative 4. So you want to flip it to the top. And there's no problem with the w to the 3rd. I would leave it right where it is. And this would be my simplified answer right here. So again, I'm not trying to teach you everything there is to know about exponents, just enough to help you on the ACT.